Hello everyone, welcome back to our Java programming course. This is session number 21 and today we are going to discuss a very important concept in Java, threads along with thread lifecycle and thread priority. I am Dr. Amit Batra and this session is planned for around 50 minutes. Threads are the foundation of concurrent programming and by the end of this lecture, you will clearly understand how Java executes multiple tasks simultaneously. Before starting today's topic, let us quickly recap what we covered in the previous session. In the last lecture, we focused on collections and generics. We revised the key concepts of the collections framework, including list, set, and map. We also solved several problems using generics to achieve type safety and code reusability. Today's topic builds on those concepts, especially when programs become large and need better performance. Let me start with a simple question. Why do we need threads when we can already run programs sequentially? Think about this for a moment. If a program can already execute step by step, why do we need multiple threads? In class, I would ask you to discuss this with your partner for 1 or 2 minutes. Keep this question in mind. The answer will become very clear by the end of this lecture. These are the learning objectives for today's session. By the end of this lecture, you should be able to first understand the concept of threads in Java. Second, explain the thread lifecycle and its different states. And third, describe thread priority and understand its role in CPU scheduling. If you can confidently explain these 3 points, you have understood today's topic well. Let us start with the basics. A thread is the smallest unit of execution inside a process. A process can have multiple threads running inside it. Java supports multithreading, which means performing multiple tasks at the same time. For example, think about your computer. You can listen to music while typing in Word. Music playback is one thread, typing is another thread. This improves performance, responsiveness, and efficient use of CPU resources. In Java, there are two main ways to create a thread. The first way is by extending the thread class. Here, we create a class called myThread that extends the thread class. We override the run method. This method contains the code that the thread will execute. Inside the main method, we create an object of myThread and call the start method. Remember, we never call run directly. Calling start automatically invokes run in a new thread. The second way to create a thread is by implementing the runnable interface. Here we implement the runnable interface and provide the implementation of the run method. Then we create a thread object and pass the runnable object to it. Finally, we call the start method. This approach is more flexible because Java does not support multiple inheritance, but interfaces can be implemented easily. In real-world applications, this method is preferred. Now let us understand the thread lifecycle. A thread does not run continuously from start to end. It passes through different states. The main states are new, runnable, running, waiting, or blocked, and terminated. This diagram visually shows how a thread moves from one state to another during execution. Let us explain each state one by one. New state. The thread is created but not started yet. Runnable state. The thread is ready to run and waiting for CPU time. Running state. The thread is currently executing on the CPU. Waiting or blocked state. The thread is temporarily inactive, maybe waiting for input or a resource. Terminated state. The thread has completed its execution and is finished. Understanding these states is very important for debugging and performance optimization. Each thread in Java has a priority value ranging from 1 to 10. Thread dot mean underscore priority is 1. Thread dot norm underscore priority is 5. and thread.max underscore priority is 10. The thread scheduler uses priority to decide which thread gets CPU first. The thread scheduler uses priority to decide which thread gets CPU time first. However, priority is not a guarantee. It depends on the JVM and operating system. In this example, we create two threads. One thread is assigned minimum priority and the other is assigned maximum priority. When both threads are started, we print the thread name and its priority. You may observe that the higher priority thread often executes first. But again, this behavior is not guaranteed. This shows how priority influences scheduling but does not fully control it. This is an interactive activity. The question is, why would we use multithreading in real life applications like gaming, servers, or banking systems? First, think individually and write your example, then discuss with a partner. Finally, share your ideas with the class. This helps you connect theory with real world applications. Now, here is a small coding challenge. Write a Java program that creates three threads, one printing numbers, one printing alphabets, and one printing a message. Assign different priorities to each thread and observe the output. This activity will help you understand how threads actually behave during execution. Let us summarize today's session. Threads enable concurrent execution in Java. A thread goes through different lifecycle states from new to terminated. Thread priority influences scheduling, but execution order is not guaranteed. These concepts are fundamental for advanced Java programming. In the next section, we will go deeper into creating threads using runnable interface and thread class along with more practical examples. Make sure you practice today's concept before moving ahead. As the question bank has already been shared with you, uh, pertinent to this session 21, now we'll be discussing a practical case-based scenario programming problem. As you can see, we have to solve this problem. A banking application uses multiple threads to handle user transactions, interest calculation, and log generation concurrently. Design a Java program using multiple threads to simulate this scenario. Assign appropriate thread priorities and justify your choices. Analyze how improper priority assignment can lead to thread starvation. And now we'll be designing a Java program and using the IDE known as IntelliJ IDEA, popularly used in various corporates. First of all, you can see here the IntelliJ IDEA IDE, Integrated Development Environment. You can see here where I am hovering my mouse. These are the four lines. You have to click here first. Then you have to go to the File menu. In the File menu, you have to go to the New menu item and then you have to click on New Project. In the left side, you have to select Java here, New Project Java, and you have to give the name of the project. Furthermore, here you have to select the JDK version. If you have already not installed JDK on your laptop or computer system PC, you can directly download JDK from here by clicking this button, and then you have to select the desired JDK. For example, I am using OpenJDK-24. 24 is the version of the Java Development Kit or Java we are using, and by the Oracle OpenJDK. After this, all the remaining settings will remain as default, and then you have to click on the create button, and you have to give some appropriate name to the project here, where the untitled has been typed by default. Okay, so I have already created this project with name banking multi threading demo. Clear? And by default, some code will be opened here. You have to type this code, and this is the main method, And the class, remember that the name of the class should be main, where the M should be uppercase. Clear? Now, we'll be writing this Java program now. Starting from the So let us design a simple Java program to simulate a banking application where multiple tasks run concurrently. In a real banking system, different operations happen at the same time, such as processing user transactions, calculating interest, and generating logs. We will represent each task using a separate thread. As you can see here, the first line of code is class transaction thread extends thread. This line defines a class named transaction thread which extends the thread class. This means it represents a separate thread of execution. Then we are having a run method, public void run. The run method contains the code that will be executed when the thread starts. Then we are having a for loop. Int I is equal to 1 is the initialization condition. Initialization I less than equal to 3 is the condition. And then we are having the increment iteration, I plus plus. This loop runs 3 times, simulating 3 user transactions. Then system.out.println processing user transaction. As you can see here, plus I. This prints the transaction number currently being processed. Then we are having this line of statement class. Let me hide this project structure. Now you can see class interest calculation thread extends thread. This line of code, line number 9. This class represents a thread responsible for interest calculation. Then we are having system.out.println. This line number 12, calculating interest for account. This line simulates calculating interest for 3 different accounts. Then we are having this class log generation thread extends thread. This class represents a logging thread used for recording system activity. Then we are having this system.out.println generating log entry. This prints log entries for monitoring and auditing purposes. Then we are having the main class in which the main method resides. So public static void main, the JVM starts program execution from the main method. Then we are having line number 28, transaction thread T1 equal to new transaction thread. Then interest calculation thread T2 equal to new interest calculation thread. And then line number 30, log generation thread T3 is equal to new log generation thread. Here we create 3 thread objects, one for each banking task. At this stage, threads are in the new state. Now T1.start, T2.start, T3.start. Calling start method moves each thread to the runnable state. The JVM scheduler decides when each thread gets CPU time. Internally, the start method calls the run method in separate threads, not sequentially. If we had called run directly, no multi-threading would occur. The exact order of the output is not guaranteed. So now we can execute this program by clicking on this green triangle run button, and I have already run this program. So this will be the output of the program. But please note that the exact order of the output is not guaranteed because this program uses multiple threads. The JVM thread scheduler decides which thread runs at any moment. Since all 3 threads run concurrently, the CPU switches between them rapidly. The JVM scheduler does not guarantee any fixed execution order. Therefore, output interleaving occurs, demonstrating true multi-threading behavior. This program clearly demonstrates how multiple threads execute concurrently in Java and why output order cannot be predicted in a multi-threaded environment. Thank you for watching this lecture. One more thing, answer to the B and C part. Answers to the B and C part have been left as an exercise for you. For the A part, we have successfully written the program, Java program, using multiple threads to simulate the above scenario. Thank you for watching this lecture. If you found this video helpful, please like, share, and subscribe to the channel. Keep practicing Java, and I will see you in the next session.